All right, good morning. Welcome to GIS 300. Glad to have you with us. And today we are talking about remote sensing. And my favorite definition of remote sensing comes from NOAA, and that is the science of observing things from a distance. That essentially means putting a camera up there, whether that's in a drone, in a fixed-wing aircraft like a Cessna, or in a satellite. And today we're talking all about satellites. So the NAPE imagery, the National Agriculture Imagery Program, is a 60 centimeter resolution air photo. So that is from probably a Cessna fixed-wing aircraft flying back and forth, back and forth, back and forth. What we're looking at right now is Landsat, I think this is Landsat 8, which you'll see a video on shortly. And what this is showing is the St. John River going along here. Fort Kent is here, of course, and this is the Fish River. And this allows us to see whether there is ice on the St. John or not. And the date here is 14 January 2020, so of this year. And moving forward, we see that it's starting to fill up here on 30 January. And here's 18 March 2020, so that's not too long ago. And we have a river full of ice. We'll understand that if an ice dam should occur here, then we will have an issue with flooding because that will back the water up on both the Fish River and the St. John, potentially flooding campus. Now, I've got very high resolution data. I just drove by here and saw the river was open, so I have some up-to-date information, so we're probably not going to have much of a problem with ice dam or flooding here this year, which is good. Don't need anything else going on. But what we're looking at here, I want to show you now, start to finish, if this lets me, how this system works. So here's Landsat Look, which you can find just by Googling Landsat Look, and it'll take you right to it. And just like Google Maps, you're going to zoom your way in here. I'm just double-clicking to zoom in. And let's say that I want to see the ice on Eagle Lake. And it's saying from 1999 to 2020. And I've got the satellites Landsat 7 and Landsat 8 checked on here. And it gives me an option for cloud cover, and it's selecting 20% or less. So if it has 21% cloud cover, it's just going to throw the image out and not show it to me. So I want to go all the way to 2020, and might as well go all the way back. So the way it's going to work is it's going to show me the most recent image first, and then go back in time. And this will take a while to load. My Wi-Fi is okay, but still. So here's Eagle Lake. There's the river coming out of there. And you can see the ice is pretty well out. And you see that every time I move this around, it reloads. So we're going to be here for a little while if we keep doing this. 87% complete. And here I'm being impatient. It's giving me photographs from space. I should be a little more patient with the thing. But if we go back here, this is an issue with Landsat 7. The thing that advances the push broom image broke on the satellite, and of course it's all the way up there and they can't easily fix it. But there's Landsat 8 again. 14 January, 30 December. So there we go. 21 December is when there is no ice on Eagle Lake. So sometime between 21 December, that's a lot of cloud cover. So there's September, of course no ice in September. And then a cloudy day that snuck in here because of this push broom issue. And then we have 21 December where it looks like some ice might be starting, but it's not taken over yet. And by 30 December, it has been covered up. So that is a real-life example of how that data might be useful. And we can see some opening here in the thoroughfare, all sorts of interesting information you can get out of this. And I'm going to move it one more time to show more of the managed forest. So we see hardwood ridges, cedar in the lowlands, loading, loading, loading. So yeah, this area has been harvested a lot recently, and as we go back in time, so there's January, January, December, November, September. So now you can see the green of the hardwoods, the light green of the hardwoods, and the darker green of the conifers. And we have spruce and fir in here, and cedar down here. That's just from knowing the area. Mixes in somewhat in there. Let's keep going back in time. So we can see July, May. Now we're getting into last winter. March 2019. So you see how, while we might have a flight every 16 days, a lot of the time it will be cloudy, and those data will not be shown. Maine is cloudy a lot. But for those times when we do have a clear shot, we can track along pretty easily where these harvests have taken place. And I'll zoom in so you can see the maximum resolution of this data set. And this is a 30-meter pixel size, where you're used to 60-centimeter resolution air photos. We are now looking at 30-meter resolution satellite photos. And let's see, so we can change the way this is displaying, make it a little more contrasty. And let's zoom out a bit so we can see that a bit better. So that gives you an idea of what we're looking at. And what's particularly interesting is something like this. We can actually see the borders between townships because the management has pretty well drawn a line here. And of course, land is bought and sold by the township in northern Maine. So whoever owns this one has done differently than whoever owns this one. So in that way, you can track land cover by ownership. And you can see along the Allagash here that 500 foot swath, I think, that buffers along the Allagash Wilderness Waterway. And then on this side, less harvesting. So part of what I want you to do today is go to Landsat Look and find some images that you find interesting and upload them as an assignment. And just you can do some screenshots, and that's easily done. But if you actually wanted to work with this in ArcGIS, and we'll do a bit of this next week, not next week, Friday. So Friday we'll do a bit of talk about the analysis of this data. But if you want to download that, that's just the Export Images button here, which gives you a choice for format. GeoTIFF is the one that you can bring into ArcGIS. And you get a couple of options here. Either one of those can be loaded in. And you hit export and it would download whatever you're looking at. So that's how you access the Landsat data. There's other data accessible through the Earth Explorer. And to access those, this one you can't click on this. If you click, it'll want to set an area of interest. So you have to scroll with a scroll wheel. But if we go on in here, then we can see, let's see, where were we? So we were just looking at this spot here. So I think this is Round Pond and the state ownership here. Yeah, there's some little patch cuts there. But if you say use the map, that will define the area that you're looking at as the area of interest. So you see how it's drawn those corners around where we were. So now I'm going to go down to the bottom and ask it for data sets, and we have Sentinel, which comes from the European Space Agency. Okay, there's some information there, and then we have an option to look at Landsat, but Landsat Look is for that, so we won't mess with that. Declassified data, there's some fun stuff in there, but not too much from northern Maine recently, obviously. The last one is from 2013, so feel free to play with that. And then there's the AVHRR and aerial imagery. That'll probably be, let's see, yeah, there's NAPE and a bunch of other options that you can access. But this is where you can access a lot of the data sets that you have already paid for as an American citizen. Digital elevation as well. So let's see what we can pull from Sentinel. So let's look at results. Searching Sentinel-2. Well, that's interesting. So we have an airplane flying across there, 2 of them. Anyhow, there is Sentinel-2, and that is the image. So that looks pretty recent. We've got ice on the lakes, and that just gives another opportunity to look at that kind of data. So there's a European satellite flying over us, and there's our own satellites flying over us, and I'm sure the Russians have a few satellites flying over us as well. But for some reason, they don't let us play with those data sets. Go figure. So that does make the point that one of the values of remote sensing data is that it's all the way up there. And if we're curious about how the Amazon rainforest is being deforested, well, it might not be practical to go down there and actually do a forest inventory on the ground and find out what's what. But if you can see it every 16 days from space, then you can make an estimation of the loss of forest cover or the conversion to cropland or loss to wildfire, which is also a lot faster than going out and doing a ground survey. And when there's something on the scale of rainforest deforestation, it's very readily, it's obvious from a 30-meter pixel size. And that's something that people have been doing since the 1970s at least, when the first Landsat satellites went up. My professor at UMaine, who taught me my remote sensing class, was one of the pioneers in that. So in the 70s, he had some publications talking about rainforest loss in South America. And that's, of course, not a safe thing to go do on the ground, but very easily done from here. A lot easier to do now than it was in the 1970s, of course, because we currently have very fast, good computers. And as frustrating as your Wi-Fi might be right now, it is bringing you imagery a lot faster than you could get it in 1972. So that is, I hope today is a sort of an appreciation level introduction to remote sensing technology. The videos that I'm linking to you, they're well illustrated. They're from NASA and the ESA and other government organizations, very well illustrated. And remote sensing as a subject naturally follows GIS. So if you were at Orono in the forestry program, you'd be taking GIS and then remote sensing. If you carry on down there, you will have a remote sensing course. If you're particularly curious about remote sensing, I believe there is an online course through Machias, maybe, but it is normally taught as a full course that comes after GIS. Since most of you, I expect, are going to finish up here, I want to take a week, so 2 class periods, to sort of discuss the basics of remote sensing. So today we're going to look at the satellites and their sensors and how they work. And then on Friday, we're going to look at how we actually process those data and how we might use the data to say when ice cover is on or off, or when we're looking at an agricultural field or a cedar swamp, or say you wanted to find out where all the cedar swamps were in the state of Maine. You can train the computer to say, this is what a cedar swamp looks like. Go find me all the rest. So if you know where 10 cedar swamps are, you can point the computer, here's 1 through 10, and then from there, it can look for the other 10,000. So that's the very basic intro, and I'll let NASA take over from here. And if you have any questions, feel free to shoot, but the assignment, I recognize a lot of you are still recovering from loss of power and trees and all that, so I don't want to load you up too much, but I'd like you to go to Landsat, find some interesting imagery, and shoot me some screenshots just to show that you've gone there and done that. And besides that, on your own honor, watch the videos that follow. I guarantee they're worthwhile. And as you get through them, you'll see what the applications of those are. So hope you enjoy, hope you're all doing well, and hope to see you all soon.